Then let's see the second reference with ASHRAE, because here as you see these data, this is based on ASHRAE Handbook 2001. Most probably you have one more recent version for ASHRAE and you will have some changes in these parameters in the revised ASHRAE version. Most probably the temperatures are increased due to global warming. Anyway, let's see which ASHRAE has such data. We can check the weather data in ASHRAE Fundamentals. We can search for climatic. Chapter 14. Climatic design information. I separated this chapter. It has this important table that we are requiring. Appendix for design conditions for selected locations. It has most of the major cities in the world. Then for any city you have these data. Latitude, longitude, elevation, heating dry bulb, cooling dry bulb, and mean coincident wet bulb, evaporation wet bulb, mean coincident dry bulb, dehumidification, extreme annual wind speed, heat, cool, degree, days. Let's see how we can utilize this table. Of course, the legends of all of these are located here above. Starting with latitude, longitude, and elevation. Those data are important for the solar intensity impacting the final load, either cooling or heating. We can check the definitions of them. The latitude is our distance from the equator. They have considered whatever above the equator is on positive direction, whatever below the equator in negative direction. We have Dubai above the equator, so they have considered this as positive value. Similarly for the longitude, they have considered for the eastern part that this is negative value, and for the western part is a positive value. If we looked for Dubai, okay, so this is Dubai, 25.25 north means positive. Let's see the HAB. Latitude is 25.3 in positive. The ASHRAE show it 0.25, but the HAB doesn't accept 2 digits. Meaning that both versions are similar. Of course, this is location not changed. Anyway, the longitude, they have considered it in negative value. This means that this city is on the eastern side of the earth. Let's see the ASHRAE. It's 55.3 east. 55.3 and east is represented in negative value. And the elevation is the altitude from the sea level, which is our reference. Here the altitude is 10. In that case, we can change this to 10. Then which of these values or columns we are considering in HAB? We are performing cooling. This is the data for the cooling. Here we have it for Dubai, cooling. Then we have 3 columns or 3 choices for 0.4%, 1%, 2%. This is 1% of the time along the year this temperature occurs, and this is 2% of the time this is 0.4%. So this temperature is rarely happening, and of course it will be the highest one among them. If we can see here for Dubai, 42.9, 41.4 and 40.2. This happening very minimum number of hours. Only 0.4% of the times this temperature occurs. Anyway, in our HAB we are considering this extreme condition. It should be 42.9. Let's see the HAB. Okay, this one we have to change it to 42.9. The next one is summer coincident wet bulb. The coincident, which is the matching wet bulb to such dry bulb temperature. If the dry bulb temperature is 42.9, the wet bulb in that case will be this value. Let's see it in ASHRAE. 23.6. Here 23.9, this should be changed to 0.6. The next item is summer daily range. It's not straightforward in ASHRAE. They have adjusted itself. If we can see here from the design temperature, where is the extremist month, this one and this one, and this is the maximum minimum. The difference between them is the summer daily range. So the difference between this value and this value is the 9.7. We can check it. 42.9 minus 33.2 equals to 9.7. And by the way, whatever highest value you are changing here, the HAB is adjusting it here, 42.9. if you change this, for example, to 43.9, then 43.9, and it can increase this also similarly to maintain the daily range. So the hub fixes the daily range and it changed the maximum and minimum. Back again, 42.9. Then the winter design dry bulb, we can check ASHRAE, the part related to the heating. Similarly here, 99.6 or 99. This is the differences with the 0.4, and this is for the 1%. Also, we will take it for the extremist one, which is this one, which is here 12.9. Here 12.2, you can change these two, 12.9. In the winter coincident with bulb, it's not valid in ASHRAE, so we will keep this as it is. Here, as we mentioned, this is related to the maximum wood bulb and the mean coincident dry bulb temperature. As we have seen here, okay, or this is for Dubai, let's say here, this is the maximum dry bulb, but is this the maximum wood bulb? The answer is no. The maximum wood bulb is here. However, this one is the coincident wood bulb to such dry bulb temperature. Again, for here, so this is the wood bulb we have considered in our project, 23.6. However, the maximum wood bulb temperature is 30.3. Note that some designers making some very excessive approach, considering the maximum dry bulb with the maximum wood bulb temperature. This is useful in some cases related to the fresh air, but however, this is very excessive and very extreme. This is hypothetically never happen. This maximum with that maximum, this never happen. However, in this maximum wood bulb temperature, the dry bulb at that time is 35, not 42.9. But you might need the maximum wood bulb temperature, and this is actually needed in the fresh air calculation in many cases, particularly in the humid weathers. You will see this in our section of this course, tips and tricks for sizing the fresh air handling unit or for calculating the fresh air load, because sometimes when you are considering the maximum wood bulb with its coincident dry bulb, it gives you higher results for the fresh air value rather than the maximum dry bulb with its coincident wood bulb temperature. The rest of items here you can check it in the ASHRAE, but it's not part of the HAB. So we'll be back again to the HAB. Then we will come to the third source of weather information,